Welcome back, student. Today we are going to start the session with module 5 lecture 4, and it is under edge detection, and this is the last lecture of edge detection. So digital image processing, EC703A, Sangita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. This is the content. Edge detection in digital image processing, types of edge detection, mathematical equation of each operator. Now this is the robot edge detector. We have already discussed this one. This is the partial equation and this is the finite mathematical kernel. This is the preview. It is the mathematical modeling. By changing the value of C, we can get different type of kernel. So if C is equal to 2, the new kernel becomes Sobel edge detector. These are some practical issues: noise suppression, localization, and this localization is very important. So localization is depending on thresholding. So depending on thresholding, how much information we want for edge and how much we should discard as a noise. This trade-off is very important, and that their start optimization, it is a big research area. Now the Canny edge detector. Canny, probably the most widely used edge detector in computer vision still now. Canny has shown that the first derivative of Gaussian closely approximates the operator that optimizes the product of signal to noise ratio and localization. Non-maxima suppression. Therefore, those which are not maximum at that particular point, those points are suppressed as a noise. Edge linking, I will discuss this slowly. Now second derivative. Already we have discussed this one. Laplacian is this equation. So it is nothing but the second derivative. Why second derivative is very useful? We are talking about this for long time in the subsequent previous lectures, because first derivative gives the idea where that changes, but second derivative gives the exact point where it changes. Means it gives the local point, whereas first derivative gives only information about the edge. Yes, there is some intensity change or not. That information we can get from first derivative, but second derivative exactly locates where that particular isolated points are, or whether it is an edge or a point. Therefore, that particular information is very important to find edge and as well as noise. Properties of Laplacian. It is an isotropic operator. In this way, we will discuss about this. It does not provide information about edge detection. It is more sensitive to noise. Laplacian of Gaussian. This is the equation of Laplacian of Gaussian. Means it is nothing but second derivative. This depends on this standard deviation, smoothness, as well as it preserves edges. Now gradient versus log, a comparison. Gradient works well when the image constrains sharp intensity, transition and low noise. Zero crossing of log offers better localization, especially when the edges are not very sharp. Now edge thinning. Therefore, what does it mean by edge thinning? Edge thinning is a technique to use to remove the unwanted spurious points on the edge in an image. Therefore, at the time of edge detection, there are lot of isolated informations are there that is not in the edge, but looking like an edge. That type of information, to remove that, edge thinning operation is done. Now the morphological operations. These morphological operations is very important in edge detection. Morphology in biology indicates the structure of human body, bones, etc. Same operation for image is used for morphological operation. For erosion, it isolates some information. It gives only a thin point that is important to object of interest. Whereas dilation, already we have studied in the earlier lecture, dilation gives the information a spreaded way. Therefore, erosion and dilation, they are just opposite of each other. Now, multispectral processing. In image processing, multispectral processing is very important nowadays, and it is a very important research area, flourishing branch, to give the detail about any landscape or any information about the texture. Therefore, already in the at the time of explaining wavelet, we have discussed that wavelet gives local information as well as global information. Multispectral is that. Therefore, wavelet is very well known process for this multispectral processing. Now we have almost come to this end of edge detection, that is to adaptive edge detection. Why adaptive? Because edge detection cannot be performed exactly on a global basis. It is adaptive, means some local features are there as well as global features are there. Therefore, adaptive edge detections are coming, and a lot of newer research is coming in this field, and very important, there lot of operations are activated, but it is a very high mathematics zone, so we cannot deal with this detail over there. But after completing the whole series, I will give the little bit of one lecture about the research, how it is moving on. We will discuss about that. So these are the references. Thank you again, and we will go switch over to some Matlab session. So in the Matlab session earlier, last day we have take this image cameraman tip and operated Sobel operation. Now instead of Sobel, here we will use now Canny. What will happen? Let's see. So it is the original image and it is the output of Canny edge detecting output. So again, I am operating this for better output to see visually. Yes. So in this one picture, it is coming out. It is nothing but and small syntax im show pair. Therefore, in one frame you can find the two images. So it is the original image and it is Canny edge detected output. Now I am using this using Sobel. It will be clear for comparative analysis. So the program, yes, this is the Sobel output and this is the Canny output. Therefore, it is quite clear Canny gives better edge detection. Here some edges are missed. See, all the grasses, lands, edge unable to find. But here all the edges of grasses, everything is coming in detail. See the back end, this image is found over there. There is some another structure is there, it is also found over there. Whereas it is almost not visible the edges. So it is clear the Canny gives the better result than that of other result. Now we will move on to another important, erosion and dilation. So this is the erosion and dilation. In the Matlab, inbuilt functions are there. So you can try out this. So we can use erosion as well as dilation. So this is I'm doing in this editor window. This is an image. So this is how it will look like after erosion. Erosion means thinning. It will squeeze, the output will squeeze. Now how it is coming? I'm just running. Yes. These are the two images. This is the original image. So after erosion, only the points are coming. Similarly, dilation also there. So this is dilation operation. So this is an image, text image. So what should be the structure shape that should be identified? So by default, you can try of your own. Just one example here. I'm giving the outline. One can do of their own. So after dilation, how it is looking, it is showing over there. Dilation means the structure is enlarged. Therefore, there should be some extra pixel associated with that. So now run the program again. So this is the original one and it is its dilation. So original image was, so this is a written like normal font, but after dilation it is spreaded. So the idea of erosion is squeezed, whereas dilation is spreading. So this is all about today's class. From next day, some security aspect will be discussed in image processing. So that is all about today's lecture. We have to conclude now. Thank you. Bye.